Hello everyone, my name is Jiaming, and in this video, I'm going to introduce our paper entitled A Study of Explainability Features to Scrutinize Faceted Field Theory Results. This work is done with Dr. Hamel and Dr. Yue Wang. In our daily lives, we can see different faceted search systems, which enable us to explore large collections of documents in many meaningful ways. For example, on the left side, we can see 3 facets of gaming laptop on Amazon. And on the right side, we can see facets on the Digital Public Library of America. Now, machine learning techniques are used to generate facets automatically when the document collection is huge. We can see machine learning facets after searching document classification interface on Microsoft Academic, after searching COVID-19 papers on SciSite, and after searching Hummingbird on Google Images. However, machine learning facets are not perfect and could make mistakes. Suppose a user wants to search papers about document classification interface. The user may wonder, what's interface Java? Is it because Java was used to create classification interfaces, or it's just a wrong label and should be user interface? Compared to conventional facets that are self-explanatory and concrete, machine learning facets are subjective and abstract. Therefore, we have a wishful thinking that in faceted search system, there are tools that explain why specific facet values have been assigned to a document. Therefore, we can locate supporting evidence for facets and make a judgment. We can understand the meaning of facet values, gain insights into how the system makes predictions, and we can even find out why the system makes a mistake. In this paper, we designed 2 different explainability features that are confidence values showing the system's certainty or uncertainty in predictions, and a sentence highlighting showing the system's rationale in predictions. The general objective of this research is to answer the following question. How do these 2 explainability features influence the way people scrutinize and evaluate faceted field theory results when facet values are machine learned? In particular, we are interested in 3 research questions. How do explainability features influence users' perceptions, performance, and behaviors? In this paper, we use the movie domain. Imagine a scenario in which a user specifies certain genres, and the system returns some movies that it predicts to match these genres. Then the user wants to scrutinize faceted field theory results of movies. Note that this study is not for the retrieval program. Instead, our task happens as a relevance judgment step. In our task, the user reads a movie plot summary and judges whether the movie satisfies a set of pre-selected genres. Each movie is associated with 2 or 3 selected genres, as the one genre situation overlaps with interpreting binary classification. The user will judge the relevance of the movie and choose to agree or disagree with the system. The user will agree with the system if the movie belongs to all of the selected genres. However, the user will disagree with the system if at least one of the selected genres is not correct. In this task, a user is exposed to 4 different system interface conditions. In the baseline condition, there are no explainability features. The count condition only shows confidence values. The send condition only shows sentence highlighting. And the consent condition includes both confidence values and the sentence highlighting features. Here, we introduce how we prepare the data for the task. The first step is pre-processing. We select the 16 most frequent genres that are also identified as topical. For example, we omit some genres like black and white and short film, as these genres are hard to be predicted from the movie plot summary. Then we filter movie plot summaries that are either too long or too short to control for variance. We then train 16 one versus rest logistic regression classifiers on movie plots and make the prediction of movie genres. As we mentioned, we only include movies that have 2 or 3 predicted genres for this task. The next step is to generate explanations. The generation of confidence values is very simple. It's just the predicted probability of genres on the movie plot. The participant is instructed that the confidence values range from 0% to 100%, and a higher value indicates the system has more confidence, and 50% means it's unsure. To generate a sentence highlighting, we apply classifiers to sentences to get the predicted probability on each sentence, which are reflected by the intensity of sentence background color. Here, we take the normalization of sentence level predicted probability. This formula indicates that we will only highlight sentences that have a predicted probability larger than 0.5, as 0.5 is the decision threshold in the classifier. Now, let's put everything together and look at the study design. Each participant will first watch a study overview video, then interact with 4 interfaces. In each interface condition, a participant reviews a sequence of 10 movies. Then, in each task, a participant does a batch of 4 sequences of 40 movies in total. Each sequence of 10 movies has the following constraints. First, it covers each topic at least once. Second, each sequence has 5 true positive and 5 false positive cases. However, the participant only knows the system might make wrong predictions. They do not know the detailed distribution. Also, there are no duplicate movies between sequences. Before each sequence, a participant learns how to use the system by watching an instruction video. After each sequence, a participant fills a survey about their experiences using the system. To control for the learning and the fatigue effects, we vary the order in which participants are exposed to interface conditions using a sliding square design. Each batch is done by 4 redundant participants. The order of movies remains the same in sequences, which means we only rotate the order of interface conditions. We launched the study on Amazon Mechanical Turk. In total, 200 participants do 50 unique batches. To ensure the data quality, we only accept responses from participants who have a median time of at least 12 seconds spent on each movie. Now, let's talk about our findings. In all cases, the analysis was done at the sequence level. For example, if we want to measure a metric, we will take the average over a sequence of 10 movies in a condition. For significance testing, we use the repeated measures ANOVA plus pepperoni-corrected paired t-tests. In the first research question, we study how explainability features influence people's perceptions, which is done via survey after each interface. There are 3 parts in the survey. The first part contains 9 items asking about perceptions of satisfaction, difficulty, confidence, and understanding. The 3 confidence items have low internal consistency, so we analyze them individually. The 4 understanding items have high internal consistency, so we take the average to form one understandability measure. The second part contains 10 questions asking about system usability. There are 5 positive items and 5 negative items. Responses from participants have high internal consistency, so average these 10 items to one system usability measure. The third part is another TLX questionnaire, which contains 6 items asking about workload. These 6 items are also averaged to one workload measure. A 7-point scale is used to all the questions in the 3 parts. Now let's look at the results. In this figure, the grid scale represents 4 different interface conditions, and a higher or lower value indicates a better situation for different metrics, as you can see from the emoji here. And also, I'm drawing red lines over the bars for a clear comparison. we find 4 trends in terms of perception. First, participants report better perceptions when the interface displays confidence values. Second, participants report better perceptions when the interface includes a sentence highlighting feature. These 2 trends indicate that having an explainability feature is better than none. Third, by comparing 2 explainability features, we find that if only one feature is available, sentence highlighting is better than confidence values. Finally, in terms of perceptions, having both explainability features available seems like the best option. In the second research question, we investigate the effects of the interface condition on participants' performance when deciding to agree or disagree with the system. We measure performance from 5 aspects. Accuracy. It considers the percentage of times participants make correct decisions. A correct decision means to agree with true positive cases or to disagree with false positive cases. Normalized accuracy. Unnormalized accuracy values do not account for the fact that some movies may be very difficult to judge than others. Since each sequence is done by 4 redundant participants in 4 different interface conditions, we use a min-max scaling to normalize the sequence accuracy across 4 participants. Yes rate. It considers the percentage of times participants agree with the system. It provides insights about participants' tendencies to agree with the system across interface conditions. Precision. It measures the extent to which participants reject false positive movies when they agree with the system. It's the number of true positive in yes cases divided by the total number of yes choices. Recall, it measures the extent to which participants agree for all true positive movies. It's the number of true positive in yes cases divided by the number of true positive cases, which is always 5. We find 3 important trends. First, participants have a strong bias towards agreeing versus disagreeing with the system. As mentioned, there are 5 true positive cases which participants should agree with, but they give the system the benefit of the doubt. Second, participants achieve the best performance with the consent interface in terms of accuracy, normalized accuracy, and precision. Our results suggest that the consent interface helps participants identify and reject false positives and make more correct decisions. Third, when 2 explainability features are both available, sentence highlighting plays a more important role than confidence values. This can be seen from comparing the condition with 2 features to the condition with 1 feature, respectively. Explainability features are especially helpful in challenging situations. In our paper, we discuss a case study in detail. It shows how these features help in certain difficult genres. For example, the period piece genre. A period piece is a movie set in the past, while the historical context plays an important role in the plot. One possible explanation is that the sentence highlighting feature helps participants understand the definition of this nuanced genre and make more accurate agree or disagree decisions. In the third research question, we investigate the effects of the interface condition on participants' behaviors. We measure behaviors from 3 aspects. First, completion time in seconds. It considers the amount of time participants take to make decisions. Second, mouse on the plot summary, percentage. It considers the percentage of time participants position their mouse over a movie plot summary. Third, sentence highlighting percentage. It considers the percentage of time participants have the sentence highlighting feature turned on for any genre. We find 3 important trends. First, participants take about 45 seconds per movie across all interface conditions. This trend proves that adding explainability features does not put extra burden on participants. Second, the interface condition has a significant effect on the percentage of time that the participants have their mouse over the movie plot summary. One possible explanation is that participants in condition send and consent make heavy use of the sentence highlighting feature, which might distract their mouse from hovering over the movie plot. Third, there is no significant difference between the percentage of time when sentence highlighting is turned on in send and consent conditions. Although there is no significant difference, we are interested in one question. Do confidence values influence participants to scrutinize genres more deliberately and less randomly? To address this question, we first compute a probability distribution over selected genres, which is a percentage of time each genre has sentence highlighting turned on. For example, we can obtain a probability distribution from condition set. In the same way, we can obtain a probability distribution from condition consent. We then compute the entropy of probability distribution and compare the average entropy in two decisions. The consent condition has a significantly lower entropy than the sent condition. This result suggests that participants use a sentence highlighting feature to scrutinize genres more selectively in the consent condition after seeing confidence values, and more randomly or uniformly in the sent condition where they do not see the confidence values. In this paper, we conducted an empirical study to investigate how two explainability features, which are confidence values and sentence highlighting, may assist users to scrutinize and evaluate faceted filtering results, while faceted values are automatically assigned and can have mistakes. We find that both features make the task easier as perceived by participants, and both features lead to better objective performance at no extra cost in time. And it's useful to provide such tools in faceted search systems when information needs are nuanced or there are many false positives to be rejected. We want to thank for the support from UNCCL's Calgary Research Grant, CIKM Student Travel Grant, and the reviewers' comments. Thanks for listening. All the study materials are available online via this link or the QR code, and you can also try the system.